Welcome! Today we're going to be talking about differentiating exponential functions. It should be a pretty brief video, because even though it looks complicated to differentiate something that looks like this or like this, it actually is only one formula. The catch is that you have to know how to do the laws of exponential notation, as in an earlier video I did, and you also have to be completely comfortable with the laws of differentiation. Now, if you're still around, I'm assuming that means that you're good with both of those, because I would not be breaking down the processes of exponential notation and of differentiation. I'll be moving straight on to how to take the derivative of an exponential function. So the first thing you need to know is the basic formula. Well, really, it's the only formula that you have to know for this. As you can see, the first step is to just write the function as it is. Then, you take the natural logarithm of the base b, ln b. And the last step, which is the part where you take what is a normal derivative, is you write down the derivative of the exponent part. F of x turns to f prime of x, keeping in mind that the f of x itself stays in the first part of the derivative. Now, this is a good place to point out that you do want to put parentheses around your b here, because otherwise it could get mixed up with the derivative of the exponential, and that would not be the correct answer. So applying these principles to a problem like this one, which is more like something you'll see in the textbook or in any of the quizzes or exams, you can see that you know the derivative of x to the 7 is 7x to the 6th power. So all that we have to do is plug in that 23 and take the derivative. And that gives you your final answer. Now, this seems pretty easy, but what happens is that you'll see a function that looks like this, an exponential function, in the middle of another derivative. And the way that works is you just slot it in like any of the smaller derivative rules. And I will show you how. Say you have a problem that looks a little bit more complicated that you have to find the derivative of. Like this one, for instance. What you'll notice is that there's an exponential function, 5x to the power of 2x to the 3rd power, hidden in there. And really, you take the derivative of the main function in the same way, but all you have to do is slot in the derivative of 5 to the power of 2x cubed, where you would take that derivative. And the rest of it works the same way. Let me show you. As you can see, the derivative works the exact same way for something like the sum and difference rule, except where you take the derivative of this part, you insert this whole thing. That's why when you see a function like this, you have to differentiate. It's handy to separate this out in a line of work just to make sure that you know what you're doing. This seems pretty easy with a sum and difference rule, where there's just pluses and minuses. But believe it or not, it works the exact same way for the product, and quotient rules. And even for the chain rules. So I will give you an example of each of those. In a problem that looks like this, what you'll notice is that it's a product rule. Alright, and as you were going to do before, I'm going to apply the product rule with the exponential derivative rule inside of it. Here we go. So, as you can see, the product rule, which I know I said I wasn't going to write any derivative rules, but the exponential rule, but I lied. So, the product rule works the same way when you slot in the differentiation of exponential functions. It goes the first times the derivative of the last plus the last on its own times the derivative of the first. You might be getting the hang of it by now, but don't worry, because I'm going to show you an example with the chain rule next, and then we'll do the quotient rule. Alright, so as you can see, what we have here is a nice, easy exponential function to take the derivative of, except then we have the exponential function raised to the power that involves the chain rule down here. Now, what I'd like to do is stop now and let you try it on your own. We will resume in a few seconds. Alright, now I'm going to show you how it goes, and hopefully you will just be checking your work so you know exactly what I'm doing. Please note, you probably caught it, but I forgot to put that little prime notation right there in my formula. But hopefully you already knew the product rule. Anyways, let's continue. Alright, there you go. Easy as pie. As you can see, it works the exact same way. You take the derivative of the function itself, and then you take the derivative of the inside function. By this point, I bet you probably got it. But because I want you to really get it, and this is one of the things that makes exam 2 so hard, I'm going to show you a quotient rule because I love writing problems that are really long and everything. Okay, kiddos and adult learners, I'm going to let you off on this one on your own. And also, because I didn't do a video when I was teaching the quotient rule, or when we were learning the quotient rule, you get a special surprise treat, which is to hear the way that I remember the quotient rule, which is a song. So starting with, you know that the derivative of high over low is low d high minus high d low over low squared. Square the bottom and put it below. So I'll do this twice, and then you can replay it as much as you want. So, low d high minus high d low, square the bottom and put it below. Low d high minus high d low, square the bottom and put it below. Alright, off you go. Alright, now we're going to do the problems. Alright, as you can see, you just plug it in there. But an important thing to note is that you can apply your exponent rules when squaring the bottom. All of this raised to the power of 2, you just take that 2 and multiply it with the 7x to make it into 14x on the bottom, 13 to the power of 14x. Alright, thank you, and see you soon for a video about logarithmic differentiation.